Hello everyone, welcome to the course Data Science, and today's topic is summarizing and standardization. Summarization means suppose when you have collected data, and for that data you have applied data cleaning, and then if there is any NaN value, so that NaN value you have treated. So now the data is ready, and before entering into the modeling, we should have some insights about the data. For that, we need summarization. So summarization means we all know that in our school education itself, we have learned the median, mean, and the standard deviation, mode, range, etc. The same thing we are going to follow, but how we are going to find out those statistical measures using Python. So we'll see with examples also. So let's enter into the topic, summarizing and standardization. The first topic is summarizing. So summarizing is a process of reducing the complexity and the size of data by extracting its main patterns, trends, and features. So this will be helpful in modeling the particular data. So the first one is centrality. So we know this mean, median, mode, and dispersion. It says about standard deviation, variance, and range. And another one is sample distribution, which is histogram, skewness, and kurtosis. So we'll see one by one. What is mean? We all know that. That is, suppose if you have some 100 data, so I want to know what is the median of this. So median is you have to add all the data and divide by 100. So it will say that average, as an average, as an average, how much or how many students have crossed this level, or suppose if we impose any level, then we can say the average. So that will give you the mean value, and median is the centralized central value. Mode is the number of occurrences, and the standard deviation is, so you have the standard deviation. For example, if this is the data dispersion, means data distribution means, so we can say this is your mean. So you have to say how far it is away from the mean, okay? Whether it is 1 sigma or 1 standard deviation or 2 sigma, likewise, it goes on. So standard deviation is x minus x bar mean, uh, the whole square divided by the total number of n. So here it is sigma, summation. Suppose standard deviation means we can take two types of data. If it is population data means n is the formula. If it is a sample data means n minus 1 is the formula. So we'll see one by one in detail. So range, you know that. And histogram will say, for example, 0 to 10, how many students have occurred this particular thing, or how many students have attended a workshop. 0 to 10 students they have attended, okay, so eight workshops they have attended. And then the other students, 20 to 30, they have attended some 15 workshops. So likewise it says the data, it says about the data histogram. And skewness and kurtosis, it also says about how it will measure the asymmetry of the data, asymmetry of the distribution. Okay, for example, if this is the distribution, let me take one more color. Suppose this is the mean value. Okay, suppose if your distribution is like this, so here it is skewed. So you have to check the tail value. So the tail value is in positive side. So this is called as positive skewness, which means the data is asymmetry, and this is how a spread is. So how far it is away from the, or how it is dispersed with respect to the median. So this is called as positive skewness. And one more is, suppose if this is the median, if it is skewed like this, so here the tail is at the negative side, so this is called as negative skewness. So it also says about how far the data is distributed or dispersed from the mean. So this is called as skewness. And one more is kurtosis. For example, so this is one normal distribution, and one more distribution is like this, and one more distribution is like this. Okay, this is some various distributions. So it says about the thickness, okay, how the thickness is. For example, if this is one pattern means, So your thickness is more, tail thickness is more. If this is your another pattern means your tail thickness is reducing. If this is another pattern means your tail still reducing. So it will say about the thickness of the tail. So that is given by kurtosis. So these are the various statistic measures. So we'll see one by one with the help of Python codes. So let's say centrality. Centrality of a data describes the center or middle value of the data set. So we know that what is the mean, what is mode, and what is median. So let's see one example. So here we are going to use both NumPy and Panda. So you have to import that corresponding libraries. And this is the data frame. So the data frame, only one column, scores. In that we have given some scores and we have to convert that to a data frame. So now data frame is ready. So on that particular column, you have to apply mean. So df. So you should not apply df dot mean. So this is wrong because under or in a data frame, we have many columns. On which column you are going to apply that mean. So that is important. So that is why data frame, in that you have to mention scores. Okay, scores should be in single quote dot mean. Similarly, median also. Then once we finalize that, then we have to print it. So this is printing one more format. Formatted means you have to create a placeholder in that this particular variable should sit on that. For that we need to use the format. So this, in this way we can use pandas to find the mean and median. One more example we'll see. One more example for mode. So for mode, again, we have to convert that to a data frame, then df scores dot mode. So in this, 100 occurs 5 times, 85 occurs 5 times, and 95 also 5 times. So since all are equal, it just says how many number of elements repeated, how many number of I mean the particular data is repeated. For example, if 100 occurs 6 times, if 100 occurs 6 times, others are 5 means only 100 will be displayed. 100 will be displayed. Okay. According, but since they are all equal, so that is why all the three are displayed. So if you use dot mode means it will give you what are the data that are repeated. Suppose if you give mode of this, mode as a function, if you use mode of this means, then it will give you how many number of times it occurs, what is the count. Okay, for that you have to import one more thing, it is scikit. Okay, so scikit library, in that you have to uh, I mean you have to call mode, import mode. So from scikit dot library import mode. Okay, so you have to use scikit library and import mode. So after imported only you can use this mode of df scores. So in this, if you apply mode, then it will tell you. I mean, in this case, it will take the least number. So we have already shown 85, 95, 100 all occurred 5 times, but in that it will take only the first number, which means in ascending order. So that number, how many times it occurs. So we can see the variations in the function. So if you use dot mode, it will give the list, but that all the numbers should have the same number of repetitions. Whereas if you give mode of mean, then it will give you the first number, minimal least number, and also the count, how many number of times it. Okay, the next summarizing is dispersion. In this dispersion, we have standard deviation, variance, and range. So let's see this standard deviation. So let's take one example. So let me take Amazon. Okay, so I want to I want to find out the sales from Amazon in India. So you have many number of cities. Okay, so you're considering only on clothing, and you have found out the sales that comes around the standard deviation. For example, so some 8.46. But the same clothing, you want to find it from cities, city-wise. For example, Amazon in Chennai, Amazon sales in Chennai, Amazon sales in Bangalore, or Amazon sales in Calcutta. So these are the three domains you have taken. And so if you find out the standard deviation means, it will be 8.98 or 8.66 or 8.84, like that. But which is greater than this. Okay, the same clothing sales, but if you want to find it out from the domain or from the particular area, means definitely a standard deviation will be more. But the same thing if you consider for a entire area, means then that will be reduced. So the first case is called as population. So how do you collect the data? Do you want to collect the data for the entire area or for the specific area, domain specific? So this is called as sample. So either are you taking standard deviation for the sample data or for the population data. So that is important. In pandas, the default one is sample. So it will not take the population. So it will take only the sample one. Then it returns the value, the sample data only. So default one is sample. So here it returns the value 6.45, which is sample data. The same thing is followed for variance. And we'll see one more example. So now I am using NP, NumPy. So np.std of this. So here I have two different things. One is ddov equal to 0. So ddov equal to 0 means it is for population. So in NumPy, if you don't mention ddov equal to 0, then it is the default is population only. But when you want to find it out only for the sample, means then you have to give ddov equal to 1. Okay. So pandas default one is sample. Pandas NumPy default one is population. You can find sample, but you have to give ddov equal to 1. So this parameter decides. So that we have to consider. So here I have shown both. So this is how your standard deviation is calculated. So you can see the sample standard deviation is 6.45, but when you have taken the population one, it is still reduced. So if you want to take the population, then you have to give d dot equal to 1. If you want to take the, sorry, if you want to take the population, you have to give d dot equal to 0. If you want to take the sample one, means then it is d dot equal to 1. So we have to remember this and choose the code appropriately. The next one is variance. So here also the same thing, np dot variance. Either are you using population or do you want sample data? So this is your population, this is for sample. And we can use dot where also. This is for pandas. In pandas, the default one is sample, but in NumPy we can change accordingly, the d dot equal to 0 or d dot equal to 1. And next one is range. So range is maximum minus minimum. So np dot max of that particular data frame column minimum. And one more thing is, if you want to use, I mean, NumPy means np dot, but data frame straight away means data frame dot max. So in this way, you can find the range. And one more example is, you can see here, this is the data frame, but here array. So if it is np dot array means you can just apply np dot max of scores minus np dot min of scores. So this is how we have to find the min value. So we have finished centrality and dispersion. Next, we will consider this sample distribution, whether it's histogram or tally, and skewness and kurtosis. So we'll see one by one. So histogram is a graphical representation, and tally is a simple counting method. Skewness measures the asymmetry, and kurtosis measure the tailedness, which means the tail thickness. So the first one is histogram. So this is the code. Okay, so for this, first you have to import matplotlib.pyplot and plt. So this is your, wherever you're plotting it, you have to use plt. And since you are going to use skew and kurtosis, so you have to import. So that is in scipy.stats, and import this function. So first we take the data frame, and then in that data frame, I'm going to draw the histogram. In order to draw the histogram, I want bins. Bins is a container. So I'm going to convert this into 5 containers. And then edge color, this is the edge color. Edge color is black. This is black. Edge color is black. And alpha is this transparency. So alpha starts from 0 to 1. So 0 is transparent and 1 is opaque. So accordingly, you can choose. So it is closer to opaqueness, but not transparent, because it is 0.7. So this is the code. Hist, open the parenthesis df dot scores. On this, you are going to apply the histogram, and How many bins you're going to make? 5 bins. So I'm going to make 5 bins. In that, you're going to draw. For example, let's say first bin is I mean 85. So first bin is you can start from 85 to 88, 80, 85 to 88. So you have 5 occurrences. So that is why 5. Okay. And then these are the other bins. And then one more bin 95. In that 95 occurs 5 times and 100 also occurs 5 times. So in this way, it is used to plot histogram. And the next one is tally. So here tally means you have to use dot value underscore counts. You have to use the same code. Dot value means it will find it out how many number of times it occurs. So 100. So I mean this occurrences should be same. Then only it will print. So since 100, 95, 85 all are same. So I mean all the value have got same repetitions. That's why it gives the value. The next one is Q. So Q of DF scores and the curtices of DF scores. So it will be printed. Okay. So here this is negative skewness and then this is negative kurtosis. So negative skewness means it is like this. Okay. So here, so this is like this. Okay. So this is your negative skewness and kurtosis means it is based on the thickness. So this picture will clearly explain what is skewness and kurtosis. So this is the normal distribution. So here there is no skewness. Whereas in this case, see the tail is located left hand side. So it has got negative skewness. Whereas here the tail is at the positive side. This is positive skewness. So in the previous data, for the previous data, we got some minus 0.15 and minus point something 6. So this is for skewness. So for this value means your spread will be like this. Okay, whereas for this 0.6, this is kurtosis. So kurtosis means it will tell you the this tail thickness. So in this case, since see this is for positive, so this takes the value greater than 3. This is equal to 3. This is equal to 3, and then this one is less than 3. So less than 3 means it comes under this. So in this case, your data will be spread. Your data spread is like this. Okay, whereas your z value, this kurtosis value is greater than 3. So why this 3 means? Actually, for a normal distribution, so we have some 68, 88, 99.7 percentage rule, which means the first deviation should occur in 68 percentage, second deviation should be 88 percentage, and then third should be 99.7. So the remaining, which means after 99.7, your data will be outlier, which does not belong to this. So that percentage 0.3 percentage, when you convert to a number, it becomes 3. That is why if any number is greater than 3, then that is called as outlier. So in this case, so here, so suppose if your data spread should be here, but if it is away from this means then that is called as your kurtosis value will be greater than 3. So there are high chances for this area to have outliers. And then here there is no outlier at all because it is equivalent to that, because it is within this. So within this area, within the 3 standard deviation. Whereas if it is less than 3 means, so here you have some outlier, but that outlier is 0 or 1 like that. So in this way, you can explain the skewness and kurtosis. So next one is binning. So in the previous case, we have done the summarizing. Summarizing means you have done mean, mode, median. And regarding dispersion, we have seen standard deviation, variation, and range. And regarding the in the plot. So normal distribution, we have seen um, this tally, histogram, skewness, and kurtosis. So this all gives you the pattern of your data, trends or insights about your data. So next one is binning. So binning means it is a classification only. There are two types of binning. One is equal with binning. Another one is equal frequency binning. So what is the difference between these two is equal binning means, so we can say the grade system in education, grade system in education. So they used to say that if you score 50 to 60, means, so we'll start from here. 90 to 100 means O grade. So 80 to 90 means A grade. And 70 to 8 means B grade. And 60 to 70 means C grade. This is D grade. So likewise, they give the grade system. See the width. The width is equal only. So if the width is equal and you're categorizing it, means then that is called as equal width binning. So how do you do? For this, first you have to take the maximum value minus min value, and then from the range you have to divide how many number of bins you want to have. So here, for example, in this, let's say maximum number is 100 and the minimum number is 62. Okay, or we'll take 60. So the range is 40. So this is 40, and I want to take 5. So it is 5. So it is 8. So we have to make the bin, the width should be 8 only. Okay, 8 is, so you have to start from 50, or since it is your minimum 60. So you have to start from 60 to 68, one bin, and 69 to it is 8. So 69 to 77 one bit. Likewise, it goes on. So this is called as equal width binning. Okay, so how do you do? First take the maximum and minimum number, take the range and divide by the number of bins. Accordingly, you can split the width. So this is called as equal width binning. Whereas equal frequency means I have to decide, I have to fix within the range only the fixed number is there. For example, this is one classification, A classification, B classification, C. But for all, you should have only four values, four values. So here you're fixing the frequency. I mean, the number of occurrences is fixed, but this width may not be equal. There is no and or necessary that the width should be equal. The width should be anything. So in that case, so that condition is called as equal frequency. So for equal frequency, how to do? First, you have to collect the number of data. For example, if the number of data is 15, means I want to make 5 bins. So each bin should have 3 entries, not the equal width. So each bin should have 3 entries. So this is called as equal frequency binning. Let's see one example. So first one is equal with, so take the data. Then for that you have to apply PD dot cut. On ages you're going to apply, then bins you're going to make 4. And for each bin you have given the label as like this. So how to do? First take the maximum, minimum, take the range and divide by number of bins. So 16.75. So according, start from the minimum value. So 18 plus 16.5. Then 34.75 plus 16.75. So likewise, make the bin. So all this have the width as 16.75. Then accordingly, you have already created the label. Accordingly, it will say young adult middle age. So you have to apply this logic for each data. So first one is 18, which is the lowest one. So young. 22 also. So up to 34.75, it is young only. Then after that, it is adult. So likewise, you can categorize this. So this is called as classifying, which is based on equal width binning. So next type is equal frequency binning. So in this case, first you have to take the number of values, divide by the number of bins. So you have 3 or 4 values because it is not the proper factor. So the answer is 3 4 so 12. So 3 point. So remaining 30. So you have 7. So either you can have 3 values or 4 values. So you can see 18 to 29. So 18 to 29, you have 1, 2, 3, 4. So you're in this number of occurrences 4. Then 29 to 50. So 1, 2, 3, 4. So here also you have 4 data. Then 50 to 70, 1, 2, 3, 4. So you have 4 data. And then remaining is 3. Okay, so either you can have 4 or 3. But see, the width is not equal. So here the width is 11, and then here the width is 21, here the width is 20, and then here the width is 15. So the width varies, but the number of entries remains the same. So hence it is called as equal frequency binning. So equal frequency binning is always for clusters. Okay, so I want to know how many of you are recruited, or how many of you need training. So those things we can collect. So there's a cluster part. But for equal width, it is a grading system is one example. So this is about binning. So next one is classifying. So classifying, we can do classification in three ways. First one is you have to give the condition and you can classify. Another one is normal binning, and another one is again condition, but in that condition you can apply selection. So we'll see one by one. So in this case, this is the data frame. In the data frame, we have student column and marks column. So convert this to a data frame. So here I have defined one function. So that function I'm calling. Okay, so I'm going to apply the category. For that, I have to apply this function. So apply is the keyword, is very important. Then the function name is classify marks. So here for every mark for 85, if it is greater than 85, I have to give the condition that condition is greater than or equal to 85 means excellent, greater than or equal to 70 means good, greater than or equal to 50 means average, and else it is poor. So for each range, some for each condition, some label is given. So that is called as classifying based on this category. So for that you have to apply classify. You don't need to give label in the condition itself. You mention, that is why see here excellent, poor, good, excellent, average. So this is I mean, how did we get this? Means dot apply or classify marks. This is based on condition. Next one is you have name column and age column. You have converted into data frame. So now it is in data frame. So here I have to give the bins. So bins have to be given. So if you want to give bins, then you have to give pd.cut, which I have already seen, on which you are going to consider the bins on age column. Then bins, already you have given the bins. Otherwise, you have to give the bins here. So bins are already given and labels are also given. So accordingly, it will label. So this is called as pd.cut method. And next method is select method. So here, first you have to make a data frame, the customer column and spending column. So here I have given the list of conditions. So the condition is, I mean, or the condition is given together. So if the spending is less than 200, then he is considered as low spender. If the spending is greater than or equal to 200 and less than 70 is moderate. Then next comes high spender, next comes premium spender. So this is also, first you have to give the conditions, then you have to give the category, then you have to give the select command. So np.select conditions is all conditions have to be applied, and categories also should be applied, because categories is given. Conditions, you have to look after the conditions, categories, and the default unknown, because we are not using any default method. So in this way, if you do, then this is the category. So there are three types of category. One is function based. If it is function based, you have to apply, you have to apply dot apply, that is custom classification based on conditions. And then next binning is pd dot cut. So in this case you have to apply, I mean, you have to group the numerical data into bins, grouping, you have to do the grouping. Whereas multiple conditions, so here it is only one set of condition, because every time only one condition you are checking, but here multiple conditions are there. So your data has to go on through all the conditions at a time. So multiple conditions. So in that case, you have to use select. In these way, you can do categorizing. And next method is standardization. So why do we need standardization? Because it's a pre-processing technique. It transforms the numerical data to have a mean and standard deviation. Accordingly, you have to do the standardization, and particularly useful when dealing with features that have different scales. For example, nowadays in almost all colleges, CSE department, you have huge strength. So your strength will be more. For other department like triple E and mechanical, your strength is decreasing. So in order to, so it has a different scale. One particular college, it has 1,000, and then here they have only 200, and this is 300, like that. So you can see the scaling. So it has got different scales. In that case, you have to go for standardization. You have to standardize the value between 0 and 1. So that is called a standardization. So why do we need standardization? Because it equalizes feature import. That is, it prevents feature with large magnitude. So we don't need to say the huge quantity. Instead, you can give the numbers with 0 to 1. So it prevents features with larger magnitudes from dominating the model, ensuring that all features are treated fairly. And for machine learning, so many machine learning algorithms, they rely on standardized data only, then compatible to certain algorithms. So if it is standardized, then it can be compatible with all algorithms. So for this purpose, we have to do standardization. So let's see. So there are two types of standardization. One is z-score standardization, another one is min-max. So in z-score, we are going to use x minus mu by lambda. So this is called as z-score. So we'll see that x minus mu by lambda. X is every data. This is your mean, then this is your standardization. So you have to find out the Z score. So from that Z score, we can easily check whether it is, whether it is within the range or out of the range, or we can get one value and we can, mention wherever it is necessary, because it has a different scale. So it is a data processing technique that transform numerical data to have a mean of 0. So this we have already seen. So this is the formula. Now we'll see the code. So in the code, simple. First, the formula is df dot values every data, and then mean. So how do I do the mean? So df values dot mean. Okay, database standard deviation. So this is just apply it and get the value. See here. So z score is 0.1, and then this. So this is the data. In this data, do you have any outlier? No, because we have already given that if z score is greater than 3, then there is an outlier. So, but the maximum z score is 1.26. Suppose if you have some not 40, 60, 70 means definitely this z score will be greater than 3. So in that case, we can easily locate whether this particular data has outlier or not. So your outlier is detected by the use of z score normalizations. So that's why here the help with outlier, the standardized values show how far a data point is from the mean in terms of standard deviation. So this is helps to locate the outlier. And next one is min max. So you have to find every value, find out the min, subtract it, divided by the range. So this is called as min max. So it is also a pre-processing technique. So it is, if you want to prevent certain distances between data points, then we have to use this min max normalization. So let's see the code. So this is your data frame, and you have to take down each value that has to be subtracted from minimum value, then divided by maximum and minimum. So if you do this, you will get the value, normalization. So instead of having lots of values, lots of scales, a huge scale, we can use the normalized value to represent it easily. And this will favor the machine learning algorithms to work with. For that purpose, we are going for standardization. So when do we use z-score? When data contains outliers, because if your z value is 3, z is x minus mu by sigma. If it is greater than 3, then we can say that this particular data has outliers. Then when data follows a normal distribution, then in that case we can use. When negative values are acceptable, then negative values means it is like this. Okay, skewness. Then when do you use min max? When data is within the fixed range, and when absolute magnitude matters and data is not affected by outliers. For these case, you can use min max normalization. So that's all for today. So today we have learned summarizing in that mean, median, mode, and next one is dispersion, standard deviation, variation, and range. And normal distribution, we have seen tally, histogram, kurtosis, and skewness. And next one is binning. We have learned in binning, one is equal width binning, another one is equal frequency binning. Equal width means the width or the range should be same for a category, whereas equal frequency means the number of occurrences for a particular category should be same. So one is for grading system, another one is for cluster data. So that is called as binning. And in classifying, we have three options. First option is PD dot cut. Next one is dot apply. Next one is dot select. So dot apply means only one condition, and select, since it is select, so select will only if you have multiple conditions only will go for select. So we have multiple conditions, and then this is normal categorizing and how to bin it and label it. So this is your categorizing. And next one is standardization. In that we have used this Z score and min max normalization. So the normalization, why we have to do is then only your machine learning algorithm can be easily applied to the normalized data. For that purpose, we have to perform normalization. Okay, that's all for today. Thanks for watching.